My name is Danny Moran. I'm an instructor here at Sprinklermatic University. This for me is a little side gig for my main job. I'm a captain on the fire department in Fort Lauderdale. And so today we're going to talk about fire pumps, controllers, and holding tanks. Basically discussing NFPA 20, which is a standard for installation of stationary stationary pumps for fire protection. All right. So if you've been to the classes before, like the guys from Pompano have, some of you guys are repeat. I always like to. I'm always been, and anytime that I'm learning about something in the fire service, I've always wanted to know where things come from. Like, why do we do things a certain way? Well, what's the history behind that? I really think as firefighters, we have to know the history. So what I've been doing is talking about past events that have led to changes, because it seems like with NFPA especially, a lot of the changes, there's always been one big incident or a couple big incidents that have really been catalysts for change. Like one Meridian Plaza completely rewrote NFPA 14 because of the disaster that happened there. So I want to talk about one disaster in particular that led to transformations with NFPA 20 and other NFPA standards. And only one of these pictures is that real incident. Does anybody recognize any of these pictures?
The one on the left is in Dubai, isn't it?
Now, the one on the left is actually a 1974 film called Towering Inferno, starring Steve McQueen and Paul Newman. So there's a really stressed out fire chief, and him and the building's architect, they had to get together and save all the lives, and the sprinkler contractor was trying to get out of responsibility and everything. So it was a pretty interesting movie. Really good cinematography and acting. Highly recommend it. The middle picture here, anybody know what building that is? That's the Nakatomi Plaza from Die Hard. All right, so the real incident that we're here to discuss and talk about the history of why things have changed was the one on the right. So this is actually a real incident picture. This was the first interstate bank fire in Los Angeles in 1988. So basically, that fire started on the 12th floor, and it gutted 4 floors of the building, and a 5th was damaged. One thing that I mentioned in the last class that we did is it also seems like all of these incidents that have major changes brought about in NFPA standards and fire protection codes, it always seems like Murphy's Law is there every single time. You guys know what Murphy's Law is? Like, if something's not right, you know, you should have expected it. So almost every single one of these things, like in this building in particular, they were working on the fire protection system. It's a 62-story building, and they were working on the 58th floor, and they had everything in the building shut down. They drained the system out, and they had all the floor control valves closed because they were waiting for the installation of water flow alarms, right? So the system was working up until 58. So from 58 to 62 wasn't working yet. They were still working on it. But up until the 58th floor, everything was totally fine. But all the floor control valves were closed because they didn't want to generate false alarms with a water flow switch. So what happened here is the fire started on the 12th floor with closed floor control valves, and also just before the workers were finishing up for the day, they went down and they turned off the fire pumps, disabled the fire pumps for the building. So that's what I mean by Murphy's Law. So it just seems like weird things always happen when incidents like this occur and fire protection codes are rewritten. Amazingly, only one person died in this fire, and it was a either a security guard or some kind of building maintenance personnel. So what happened is the guys were working on the 58th floor, and they still had workers up there finishing up work, and some had left, and the ones that left turned off the fire pump. Smoke alarms started coming in on the 12th floor, and the guys down in the lobbies at the fire control panels were just resetting the system. Just reset it. They're working on the system, right? So they're just hitting reset. That was one smoke alarm. About 5 minutes later, they had 3 other smoke alarms on the 12th floor, and they reset all 3 of those. And then a few more minutes go by, and now they have 4 more different smoke detectors activated, and they reset all those and then say, you know what, maybe somebody should go check this out. So one guy gets in an elevator and goes up to what floor? The 12th. The door opens up on the 12th floor. Smoke is billowing and flames are flowing inside the lobby right there at the 12th floor because one of the maids, when she was leaving, she left her cart in the path of the door that was supposed to isolate the lobby for the elevators. So now the guy that went to check out the smoke alarms, he ends up dying right there on the lobby of the 12th floor. And 35 other people injured, 14 firefighter injuries, significant monetary damages. It's amazing when you really think about a fire like this, how only one person died. And it was really like to give the firefighters really good credit here. They really did a bang-up job. They really planned their attack very well. They had 60-minute bottles on scene, and they also had 30-minute bottles on scene. And ironically, you know which ones they used? The 30-minute bottles, because they didn't want to overwork themselves by using the 60s, so they just rotated back and forth through, more rotations in and rest in between, and more fresh guys going in on 30-minute bottles as opposed to crews over-exhausting themselves. And they fought this fire from inside using 4 different stairwells and eventually put it out. Just went floor by floor by floor. Yes, sir?
What initiated the fire?
I don't know, to be honest with you. I don't know what it was. But it definitely started there on the 12th floor. Once the windows on the 12th floor gave out, and it started auto-igniting up the building. Like I said, it's amazing that it stopped right there. You see that picture of the helicopter up there? So the helicopter was rescuing people off of the roof. A couple of people that they rescued off the roof were some of the workers from the sprinkler contractor, and the helicopter was taking people to the police station. So when the sprinkler guys got to the police station, they told people there, hey, you have to get us back to that building as soon as possible. We're working on the system. We know how to go turn on the fire pumps. We can help get the firefighters water in the building. So they brought them back. And with all the glass that was falling, they had to get a lot of protection. They had to get plywood and put it over hoses, because the hoses were getting sheared by falling glass. That's probably where most of the injuries came from, was really falling glass. So really big event, really changed a lot of the codes and the standards. All right, so basic, that gets us into NFPA 20. And I also like to talk a little bit about the origins of where NFPA came from. Back in 1895, it started with insurance members. You know, they wanted to get together and create a standard for these fire protection systems because there was nothing in place. So when somebody went to go work on a system or install sprinklers, the people who were doing all of the work were plumbers. They were the ones that were doing sprinkler fitters' jobs today. And there wasn't anything in place for a standard, so people would go to one building and try and figure out how they did something and fix it, and then they'd go to another building and see something completely different, and so nothing was standardized. So the insurance industry wanted to standardize the way things were done. A few guys got together, and in 1896 they released the first standard, which was NFPA 13. They were called pamphlets back then, because that's basically what they were, pamphlets like this big. And now NFPA 13, like if you want to read it, have fun. That is, it's a big read. Almost all of them are 100 pages or so with the appendixes and everything. So they definitely changed. Back then, all of the members were all from UL. On the board, there was only a few of them. And now today, it's a whole gamut of people: insurance companies, government officials, engineers, sprinkler contractors, installers, fire department schleps like myself. I'm on the NFPA 14 tech committee. So it's a really good, like, vast majority of people that get together and help basically design what the future fire protection systems are going to be. All right, so talking about early fire pumps, they were basically there for secondary supply for the sprinklers and the standpipes. They were only started with a manual start, and a lot of them had other functions. They were being used to do other functions in the building, like sometimes even supply domestic water or do cleaning purposes. So today's fire pumps, obviously you can't do any of that stuff with. They're strictly designed for fire service only. The actual way that they operated is that they took suction by lift from standing or flowing water supplies, because that's what the national standard was back then for steam fire pumps. That's what they had in place. The advent of centrifugal fire pumps really changed the way that pumps were going to be designed and carried on through up until today's current standards. You did have gasoline-driven engines back in the early 1900s. You won't see them anymore. The compression ignition diesel-driven engines really have become very popular. Vertical shaft turbine pumps. We were talking about this a little bit the last class that we did with Bill Gusson that was here. He was telling me that a lot of areas down in Homestead, like the rural farmlands and redlands down in Homestead, they still have vertical shaft turbine pumps because they are directly connected to like the reservoirs and ponds and wells underground. And he was showing me some pictures of them. It was pretty interesting. So fire protection today calls for larger pumps and higher pressures, and it all basically depends on the occupancy of the building. The hydraulic calculations that NFPA 13 will require for the fire protection system. Now, obviously, the main function of the pump is to increase pressure of the water flowing through it and also provide extra volume. Where are we going to see these pumps? Anywhere where you have a building where the water pressure and volume and duration is not adequate to meet the demands of the automatic or manual fire protection system, then you're going to have a pump on site to meet that need. You have minimum water flow requirements through NFPA, and again, it's all based off of that occupancy class and fuel loading considerations. You know, what type of building is it going to be? Is it a residential high-rise? Is it a commercial building? Is it a football stadium? You know, is it an airplane hangar? Is it very highly flammable materials? Everything is going to have a different occupancy class, which determines the hydraulic calculations, which determines the minimum water flow requirements, and then that will lead to whether or not the pump is required and what type of pump it's going to be. Anybody have any questions or anything to add so far? Like I said, please feel free to interject and add, because like I said, I'm not an expert on this stuff by far.
So on those line shaft turbine pumps, because we manufacture those and we sell those into the fire pump market.
Okay.
And they're pretty, not common, but they're not unusual to have that application.
Right.
So.
And that's what I learned last day from the captain from Miami-Dade, that they are not uncommon.
Right.
You know, like I was saying that they were kind of being phased out, but he said absolutely not. Like especially down here, like in South Miami-Dade, he said even areas around here, some like older parts of Davie or even out west, like Southwest ranches, may have some areas where you may have some of these pumps. So I don't know.
Churches, the rural churches that are outside of the things, metro area, and they're out in the rural, well, they don't have water supply sufficient. They'll drill a well and use a little turbine pump for their water source.
So that's not an uncommon thing. So, yeah. Yes, sir.
For us going to the building, what do we measure if it's horizontal or vertical? In terms of the function of it, is one.
That really, it doesn't matter for us. Yeah, horizontal or vertical doesn't really matter for us. And we'll get into the different orientations of the pump, but for us as firefighters, it doesn't really matter. It all depends on the engineer designing the building. How much space do they have in the pump room? If they don't have a whole lot of space, you're going to see a vertical shaft pump as opposed to a horizontal. But the type of pump that he's talking about in particular is because of the area that it's in, right? So like all the way down in South Dade, there's not really a whole lot of water supply around. So they have to get it from reservoirs on the ground, and that's where the vertical shaft comes in, right? Okay, so, but speaking of that, so where does water come from? Obviously our main supply, or the systems have to have a primary supply, and some are going to require a secondary supply as well. The main place that you're going to see water supply is from a public water main. Sometimes it's the only service available, or sometimes down in the redlands like that, the only water around are the lakes and streams, reservoirs. It all depends on where you're at. Sometimes storage tanks. All right, so there's lots of different places where we can get the water from. Anytime that building is being designed and a system is starting to be put into place, way before we do that, we need to know what kind of water supply we have available there. So extensive water tests and flow tests are conducted on hydrants in the area and stuff to make sure that the requirements are there. And everything is based off of those flow tests. One thing that NFPA 20 will allow is a 1-year gap between the flow test to when the building is constructed. So if they do a water flow test, they have 12 months before they need to redo a water flow test if the system isn't in place yet. Just make sure that nothing has changed. Another thing NFPA 20 requires is that a sole entity have unit responsibility. So what I say by unit is basically the fire pump unit, and that includes everything that goes with the system. It's the pump, the driver, the controller, and all the accessories, even the fuel tank, right? So you have flow meters, relief valves, every single part of that fire pump unit. NFPA requires that one person has sole entity of it, right? So if there's an impairment, somebody is going to take responsibility. Sorry about that. The only thing that they don't say is who is going to take the responsibility. They just say somebody's got to do it, but we don't care who, one person does. What FM requires is that FM will require the manufacturer to take sole responsibility of the unit. So at least there's like a checks and balance system there. You know, as everything is UL listed and factory mutual approved, NFPA requires that one person have sole responsibility if something goes wrong, but they don't decide who's going to do it. And factory mutual says, I'm going to tell you who, it's going to be the manufacturer. All right. Centrifugal pumps, these are the most common type of pumps, fire pumps that you'll see, installed either horizontal or vertical, like you were just asking me there, sir. And for fire service, it doesn't really matter whether it's up, down, sideways, whatever. It's just we need to know if it's there and what pressure it's running at. So you'll hear terms called horizontal split case or vertical split case. The split case basically means that just the casing for the shaft and the impeller is split right in the middle, and you can take the top right off and expose everything. So for mechanics, any mechanics that work on pumps in here, or any of the engineers work on them? You work on this as you work on the pumps?
It's not on my buildings that I do.
Okay, so do you ever take the casing off there? And
Sometimes when we get here, we do it.
Yep. Oh, that's pretty cool. So you take the case off there, and it's as a guy performing maintenance, they're great, right? Because you have everything right there that you need to work on. The shaft, the bearings, the impeller are all right there. You do your work, you put the top of the casing back on, job is over. This is, I'll premise this by saying this is not a split case pump or horizontal split case pump. This is an end suction, but it's cut in half there so you can basically see the way the water is going to flow through. There's like the other diagrams and images that I found for split case pumps, like water flowing through it. They weren't very good, and this was pretty nice to look at. It was easy on the eyes. It's just not a split case pump, but at least you can see where the suction comes in, goes around through the impeller there, and then out the discharge. All right, so of these centrifugal pumps, the horizontal split case is the most common type. You have grease fittings for the bearings at the end of the shaft there for lubrication. There's packing in there. It's part of the stuff for inspecting and testing. And even as fire service members, when we go just checking out a building, when we go to a pump room, we want to make sure that we see water dripping from certain places, and not too much water and not too little water. A lot of times what happens is that people will see water dripping from the packing. You should have like a drop every second dripping from there, and people will see that water dripping and they'll come in and want to tighten it. And when they tighten it, that provides for not water dripping, which means that the pump is not cooling itself, which means that when the pump is running, putting a fire out, working in our favor, now we're at risk for the fire pump to burn up and shut down. So it's very important for maintenance to understand that, you know, water dripping like that is important. All right. So we don't want to have too much or too little, about a drop per second, and we don't want to loosen or over tighten the packing. This is that horizontal split case. All right, so you have the actual the pump right here. This is the horizontal split case pump, and this is the motor that we'll talk about in a minute. Here's like a little cutout of what it looks like when you take the casing off of there. All right, so water is going to come in that suction and then go right out through the discharge. Everybody good so far? Questions, thoughts, things to add? All right. The horizontal split case, you can have a counterclockwise or clockwise rotation for the electric. For the diesel horizontal split case, they only operate in the clockwise direction. You have single and multi-stage impellers and multiple impellers on the same shaft. So basically what that means is that you can have a multiple stage pump so that water is continually boosting, the pressure boosts inside of it, or you can have different pumps in series where water goes from one pump to the next, and now we're increasing pressure and volume. right? Almost like a fire truck with a two-stage pump. You're going to get more volume at lesser pressure than you would with a single-stage pump. These NFPA will say that you can have standard and special materials. The standard materials that are manufactured with these are cast iron and bronze fittings and adapters. The special materials all have to be approved by Factory Mutual. All right, so this is the vertical split case. Basically the same thing as horizontal. It's just stand up. It saves floor space. So smaller pump rooms, buildings where you're not going to have a very large pump room, you'll have a vertical split case fire pump. And it's basically the same exact function as horizontal, but just different orientation.
Excuse me. Sir.
Yes, sir.
I'm in the engineering side, so we generally don't have space. Does a vertical pump is a lot more expensive or anything, or just limited on size? Maybe we don't get that many horsepower.
I don't think there's any different. Guys in sales, do you see any?
No, it depends on the flow and pressure that you want your pump to put out. The orientation doesn't necessarily have an effect on the price.
But then, you cannot get so big of a pump on vertical pro.
You actually can mount the same pump vertically as you did horizontally. It's more complicated, and your maintenance guys are going to hate you.
Oh, that's not a problem.
Yeah. Yeah, like this guy, when he shows up to work on a pump that you're putting in a vertical position, he's going to have to take off the entire driver to do the maintenance. As opposed to if it's horizontal, if he's working on the pump, all he has to do is take the casing off the split case. But if he's working on the vertical pump, he's got to take he's got to take all of this off, the motor, the driver off to work on the pump.
Okay.
Right. So that's really, it makes his job harder.
No, but the frame is different when you do vertical.
Good, yeah. But happening is the architect generally we don't have space, but that said, I can point out about the hard maintenance, but that's not a strong.
It's not a consideration, right?
No, on paper doesn't matter. But no, good to know. I just want that. So yeah, we'll keep it at the horizontal when possible, just to know the vertical.
Sure. Okay. The other thing I was going to say is that if you are doing a vertical, it has to be an electric fire pump, right? We can't have a diesel fire pump.
I don't think anyone has vertically mounted.
Okay.
Yeah, it has to be electric. So that's the thing. If you're looking to design a fire pump room and you want to have space saving and do a vertical pump, it has to be an electric pump. So that may be one thing that you look into also. Did they want to have a diesel? Is it going to require a diesel? Because if it does, then you have to have space for the horizontal. Right? So vertical inline pumps, these are again electric motors only. With this one, this is a little bit different from the centrifugal split case because you have the suction and the discharge are 180 degrees from each other. Standard fittings only here for cast iron and bronze. Again, these work in small space, ease of installation. All right, but the entire driver has to be removed for repairs. All right, there's a little diagram of that vertical shaft turbine pump that we were talking about. So Captain Gusson, he was referencing this. He showed me pictures of a place that he took pictures of. It basically looked just like this setup right here. And this is a cutout of everything, how it looks going into the underground. I'm sorry? What's that?
I was just reading.
Oh, okay. So that's the cutout of what it looks like going into the underground, and this is what it looks like above. So that's where those are getting their water from. All right, ponds, underground tanks, and wells. These pumps can be electric or diesel. Capacity up to 5,000 gallons per minute, 350 psi. And this one also standard and special materials. The reason why they say that you can have special materials with this is because you may run into a lot of salt water when you're going underground, especially down in South Dade. So those special materials have to be materials that FM is going to approve to go into the underground being exposed to salt water. The cast iron and the bronze won't work there.
And we do them at some marinas where they use the salt water. And pump out of there with a nickel aluminum brines construction for salt water.
What is it? Nickel what?
Nickel aluminum brines.
Okay, nickel aluminum bronze.
Interesting for salt water.
Now, when you say marinas, that's like any marina along the river, like in downtown Fort Lauderdale. So I may see some of these pumps.
So they're using that to fire protect the storage of the boats inside.
Right.
And the marina itself as well. Yes. So I mean, the last one I did was over on Pine Island, at the Pine Island Marina, on the west coast, and they just pull the water right out of the Gulf for a source.
Really?
They use them on the oil rigs also.
Oil rigs, you know,
They use what?
On the oil rigs.
for the offshore oil
Oh, the
rigs.
oil rigs. Okay, yeah. All right, that's interesting. So these are, that's more places that, I wouldn't expect to see them. So do you know, by any chance, are there any of these types of pumps in any of the marinas along, like, say, the New River, or like along Davie, along 84, going into Fort Lauderdale?
Well, not locally, but we did one up in Brunswick, Georgia. A company was putting a storage warehouse right on the Brunswick, that river up there, I forget the name of the river. But they mounted a turbine pump right there off the dock in the river to protect that warehouse with a turbine pump. So anywhere that if salt water is available and they can use that for a source, certainly they
Sure.
apply it that way.
One thing that we were discussing in the last class that we did, do you happen to know if there's any more steam pumps around? Steam? Like, we were thinking that maybe somewhere up in the Northeast, like, in New York with Con Ed or whatever, I don't know if they...
I haven't seen one. NFPA still allows it.
Right, because it's
And
still
they
in the
still have the whole
standard,
section.
so I know that they still exist, I just don't know.
I don't think it's South Florida.
Nowhere down here, yeah.
Up north.
But we were just thinking that maybe up north somewhere, like in the Northeast, that you can still see some steam pumps around.
Well, because the cities provide the steam for the buildings.
Right.
And there's a central steam section. So I can see maybe New York City, one of those, but still have steam.
Right. Okay, interesting. I'll have to let him know. So we were talking about that. Bill was wondering, he said he was going to talk to somebody, see if they still have them in New York. So we were wondering about that. This is another type of pump listed in the NFPA 20. It's an end suction type. It's the most basic type of centrifugal pump. This is the one that I showed you, the first picture, the cutout with water flowing through it. This is a single stage pump only. And this one differs itself because the suction comes in and the discharge goes vertically right out of the impeller. And this is good for floor space, right? Saving space also, so maybe something if you want to look at. And from what I hear, they're pretty cost effective and easy to work on, right? Okay, so now talk about the pumps, now we'll get into the driver. So the driver is basically what type of engine or motor is turning the pump. You're either going to have the electric, diesel, and NFPA 20, like we talked about, still mentions steam, and it's still approved and listed in the standard. Whatever it is that's powering it, you got to have enough power to turn the pump at its rated speed under all required load conditions. The three most important load conditions that we talk about with the fire pump are its churn, design, and max flow. So the churn pressure is basically the fire pump is on and it's running, but there's no water being discharged anywhere out of the system. That's called its churn pressure. The design flow is, you have your NFPA 13 hydraulic calculations for the building, and whatever type of water is supposed to flow out of the most remote heads. If you have a sprinkler head that's open either due to a fire or a broken pipe, and you have water flowing through the system, the design flow is you're getting 100% of the pressure at 100% of the flow. And then the max flow for the fire pump is, I want to say, 150% of its capacity, and you're supposed to get 65% of the volume out of it at 150%. Okay, and then you have the pump and the driver are all mounted together onto a base plate and installed there in the fire pump room. So the type of motors that we'll talk about are the electric and diesel. So the electric motors, they have to meet some safety standards from the National Electrical Manufacturers Association. That's what NEMA stands for. Basically, you have to have adequate horsepower to drive the pump, and they're rated for continuous duty. So the one thing that these fire pumps are all designed to do, one of the superintendents for Sprinklermatic, his name's Adam, really good. He says, they're just meant to destruct. They're meant to run to destruction, right? So they're not really supposed to stop, and that's why they have to have this rated for continuous duty. And they also have to be listed specifically for fire pump service. All right, so here's diesel engines and a little picture of the diesel engine and fire pump room. We'll talk about this whole picture, breaking it down a little piece by piece. The diesel engines have been proven to be the most dependable internal combustion engine. I think I read somewhere that they're pretty much at about 65% of the installations nowadays. I don't know if you guys that are in sales and manufacturing, if you can agree or confirm. I don't know. Just something interesting. I think that a lot of diesel engines are being installed over electric. Has to be UL listed and approved by FM. All right, the only thing that's going to shut this diesel engine down is the overspeed. All right, so it's meant to run to destruction. The only thing that's going to turn it off is if it exceeds its max RPMs. There's other devices on here, tachometers, oil pressure gauges, and temperature gauges, and we'll talk about that. Let's see, set to maintain, rated pump speed. All right, so if the engine speed exceeds 20% of the rated speed, the governor is going to shut that down, and then you'll end up getting that trouble signal to the fire alarm control panel. It's the only thing that's going to turn that engine off once it's if it's started manually or automatically. The only thing that's going to shut it off is the overspeed. All right, so here's a little instrument panel that's on the diesel pumps that will show you the tachometer and the oil pressure and water temperature. And again, all of this stuff is requirements of NFPA 20. That these things have to be on diesel engines. All right, the batteries right down here. All right, so you have to have storage batteries there. You have to have two means for recharging. One may be the generator or the alternator that comes with the engine, and the other can be an automatic charger. It has to be the charger. If you're going to have that there, it has to be incorporated into the design of the controller. We'll talk about the controllers in a minute. They have to recharge those batteries fully within 24 hours. All right, so I'm going to go back. To that picture just a second after we talk about this. So they also have to have a closed circuit type of cooling system. All right, so it's basically water driven by the engine. So water on the discharge side of the pump in the special piping arrangement with bypass valves and pressure regulator and pressure gauges flows out of the discharge side back through the engine to cool it. And that's what this little assembly is right here. All right, so you have the actual engine or the fire pump here, right? This is the controller. There's the batteries. And right here, this is that loop system, the cooling loop system for water to flow off the discharge side and run itself back through the fire pump. Now with this piping arrangement, there's a manual and an automatic flow. And if you can see, and we'll show you outside there too. Let me see which one it is. So see right here, this valve, is that the valve? Looks like this valve has the handle pointing down. So if the handle's pointing down, that means it's closed. So that's the manual one. So the automatic is always open. And that's where the pressure gauge is as well. All right, so water is going to flow through there off the discharge side where the pump is running to cool it, right? So it doesn't overheat. And with the electric pumps, you have the water flow, the cooling mechanism is the casing and relief valve, right? And packing the water flowing through there. All right, so the diesel engines also, NFPA has requirements and standards for the fuel storage. Obviously, it has to be safe storage and transmission, adequate supply of fuel to run the pump, and a containment method for environmental purposes for leaks and problems with the system.
Do you know how much time they need to be stored for the design timing for the diesel pump?
I do not.
It's not based on design time anymore. It's 1 gallon per horsepower the engine produces, plus 5% for sump and 5% for expansion.
There you go. Perfect answer. So what is it? It's 1 gallon per horsepower?
1 gallon per horsepower the engine produces, so it's nameplate horsepower.
Yep.
Plus 5% for sump at the bottom of the tank and 5% for expansion.
Okay.
Thank you.
Thank you. All right, so getting into controllers. Everybody good so far? Questions? Any more thoughts? Comments? All right. So the controllers for these systems. Electrical control panel used to turn the system on and off, and it's basically the brain of the system. All right. They have a sensing line inside that will sense when the pressure drops enough for the fire pump to turn itself on. interesting design concept here is that it's a fail-run design. So basically, something in the system has to fail in order for the fire pump controller to turn on, if that makes sense, right? So that's why it's called a fail-run design. And what I mean by something has to fail is that the pressure has to drop, all right? More electrical safety considerations here. The NEMA, it's called a NEMA Class 2 enclosure. The doors for it, all right, basically saying it's splash-proof and it has a withstand rating. So the common one is has a 100,000 amp withstand rating, meaning that if some kind of electrical problem were to occur in there, generate 100,000 amps of electricity, that the doors wouldn't blow off the hinges and blow open. So you have 100, 150,000, and 200,000 ratings also. You have that sensing line inside. It's usually located down in the lower left part of the control panel inside. And you have manual emergency run mechanisms. You have the transfer switch, disconnecting means to the building supply. These things are directly hooked up to power coming into the building. So anytime that somebody has to perform maintenance on this, there's probably at a minimum of 480 volts of electricity coming in behind those doors. So anytime that somebody's got to work on it, obviously it's got to be a certified electrician capable of doing so. Here's a closer picture of that. So you have your on and off switch here. You have a manual start button. The green and the red is the stop. And these controllers, if you manually start the fire pump at the controller by pushing that green button, the only way that that pump is going to turn off, aside from if it's a diesel engine with overspeed, the only way it's going to turn off is if you go manually turn the pump off now as well. When it's in the automatic setting, it's supposed to turn on automatically, and a lot of them have run timers. For electric motors, it's a 10-minute run time, and for diesel, it's a 30. So after 10 minutes, if the fire pump is running, and after 10 minutes, pressure restores itself into the system, and there's no more water flowing, the pump will continue to run for 10 minutes before it automatically turns itself off.
That's what, 10 minutes for diesel?
10 minutes for electric, and 30 minutes for diesel. Yes, sir?
On the previous slide, there was a statement that said second from the bottom connects directly to the building power. I don't think it does. It connects directly to the utility supply.
To the utility?
Yeah, because building.
Yeah, that's what I meant.
Maybe
maybe I should reword that line there.
Yeah, because it's a violation to have it connected to the building power supply.
Right. Yeah, like the power from the utility comes directly into the control.
Yes.
That's what I meant to. That's how I meant to word it. I'll change that line. Thank you for pointing that out.
Have you seen like AC in the fire pump room because the controller? I'm asking because, for example, fire alarm you need to have AC, and it's more for the humidity control of the panel itself, of the electronic components. That cannot be more than 90%, 95% humidity. The only way you can guarantee that is with a climate control system. Does that happen with the fire pump controller? All the electronics there, they're like they can handle 100% humidity, or I'm guessing.
There's options you can buy with the controller. There's humidistat and a space heater that's inside the controller. You can also get it with just a thermostat.
Okay. And generally, temperature is not a problem, right? It will be more the humid, or well, temperature over 200 and higher, but
can be a problem. But yeah, we sell that option a lot, either with the thermostat or with the humidistat, and both are intended to keep the condensation from forming.
Gotcha. So I can put I can ventilate the room to keep the temperature a little bit more controlled, but the humidity can be controlled through the.
You're not really controlling humidity. You're keeping condensation from forming inside the controller with that space.
Okay. Perfect. Thank you.
All right. So the controllers for the diesel pumps also meeting the electrical standards from NEMA. It's a Class 2 enclosure. We talked a little bit about that. And a manual start button for each battery set. Some of the newer ones, like the one that's out back here that we'll show you in a minute, it's really new technology. It's all digital. And you can actually look right at the fire pump curve on the control panel. It's a really like high-tech technology, but it's stuff that's going to be coming out. It's pretty much going to be standard. Like you guys that are doing sales with the control panels, can't remember the name of the type of technology that's in there. Under brain fart. Do you guys know what the name of it is by any chance?
That HMI, the touchscreen?
I think, yeah, it's a touch screen. Is that what it's called, HMI?
HMI is a human-machine interface. Yeah.
Oh, okay. All right. Human-machine interface. All right. All right, and then you have the fire pump accessories also. Remember, we talked about everything as a unit, and you have the pressure relief valves. With the electric, you have the casing relief valves, and with the diesel, you have that cooling loop system, and they all have the main relief valve as well. Let's see here, the pump pressure. All right, so these the relief valves are all going to be located on the discharge side between the pump and that check valve. Talk about the casing relief valve with the electric fire pump. The diesel has that water cooled through the cooling loop. All right, jockey pumps. Jockey pumps are basically the maintenance pump inside there, right? So the jockey pump's main function is to prevent the main fire pump from turning on. And the reason why it's there is to adjust for fluctuations in pressure, right? So if there's a leaky sprinkler head, like outside here, when we go out back, you'll see that there's a leaky sprinkler head, drips water. So every now and then you'll hear the jockey pump turn on. The jockey pump is turning on just to keep pressure up in the system to prevent the fire pump from turning on. Usually there's a 10 psi differential, so let's say if the fire pump is set to turn on at 150 psi, the jockey pump will be set at 160. So anytime the pressure drops below 160, the jockey pump will turn on, boost the pressure back up, and as soon as the pressure turns back up to 160, the jockey pump turns off. So it's not like the electric and diesel where they have the run timers where it runs a certain amount of time. It just does its job, gets the pressure where it's supposed to be, and stops. Okay, so when you're doing inspection and maintenance, one thing that you're going to have to do when you go into the rooms is check to make sure the jockey pump is able to turn on and keep the pressure back up, and it's usually done with the inspector's test relief valve right there off the controller. What it's not supposed to do is provide pressure during water flow conditions. So if one sprinkler head in the building is open, whether due to a fire or a broken pipe, the jockey pump's not going to be able to keep up the pressure, and the fire pump will turn on at that point. And it does have a separate controller as well. So testing, inspection, and maintenance with NFPA 20 and NFPA 25 covers some of it as well. This is that picture again off the Panorama Tower down in Miami. They were flowing here 250 gallons per minute at 100 psi residual out of that hose line, 84 stories up in the air in downtown Miami. So anytime I hear that, I'm like, man, that is incredible. 84 stories up, flowing 250 gallons a minute out of a hose line with good pressure. That's awesome. Using the building suppression system, and they also shut the system down. And with their fire trucks, they were doing training to try and get their pressure up there as well. They actually ended up burning up one of their trucks because they were trying to they were pumping in series, pumping like tandem pumping. One of them was pumping too much and ended up burning up the motor. I think there's a video of it on YouTube. I haven't seen it yet, but we have to look for it. As firefighters, this is one thing I always look at when I go into a building to inspect it, look at the fire pump, see what kind of pressure we're going to overcome, because as firefighters, what we have to remember is that the building is supplied through water by one means during a fire. It's either the fire pump and the system doing its job, or it's the fire truck pumping the system. It can't be both. So in the fire service, we always say that we want to connect to the building to augment the system, or like to back up or boost pressure to the system. Everybody has a different word for it, but it's basically we're just there on standby. It's like that standby generator. In case the fire pump goes down, we're there with our hoses hooked into the FDC to pump the building. But what's important is that we have to know what pressures to pump, because it doesn't matter what floor the fire is on. If the fire is on the 5th floor or the fire is on the 40th floor, if the building is 60 stories, we have to pump that building like we were pumping to the roof at 60 stories. Otherwise, we're not going to get the water that we need no matter where we are in the building. So it's important to come in and look at the specs of the fire pump. This is just one of the pump placard plates that I took a picture of. So you look and see what the pressures are. I was talking to some of the guys back here that really know their stuff, and basically for firefighters, when we come in here, we can look at this nameplate, or under fire conditions, what we want to do is go into the pump room and determine, is the pump running? If it is running, is it flowing water? And just look at the pressure gauges. So whatever is on the discharge side of the fire pump, that's the pressure that we're going to have to overcome to pump the building. So if the fire pump is fluctuating between 200 and 220, the needle bouncing around like this on the discharge side, as firefighters, we have to tell our driver outside, if the fire pump goes down, you're pumping this building at 225. Right, so we'll put 150, like a standard 150 into the FDC just to hold pressure, but our water isn't going anywhere. It's going up against a closed check valve on the discharge side of that pump, and we're not moving water. So another thing that's important for us is to have that driver outside that's pumping the FDC to understand that there's no water flowing, and to open up a relief valve so that we have water flowing through our pump so that we don't burn our trucks up, right? Because that'll end up happening as well.
Our new buildings, they're putting that PSI on the
Yes.
FCC.
Yep, that's a new requirement of NFPA to put the sign on the fire department connection. A lot of places you'll see that those fire department connections will have a low zone, a mid zone, and a high zone. You know, some buildings will have 3 fire pumps, like that Panorama Tower has 3 different zones in it. There's a building in downtown Fort Lauderdale on Las Olas that just went up. It has 2 fire pumps, a low and a high zone. And the low zone is labeled at 250 psi. The high zone is labeled at 350. So everything is right there for us, which is good. It's just that now that we know the pressure.
Well, what is the truck doing at 350?
Exactly. What is the truck doing at 350? It's going to burn up.
And not put much out. I mean,
Exactly.
RPM goes way down.
Exactly. So what we have to do at that point is what they were doing down in Miami to try and get that water. We have to relay pump, especially right now. Like my engine that I'm in right now is a single stage pump. And we have a new engine that's coming in. It should be here within the next couple of months. We're going back to 2-stage pumps, but our 2009 fleet that we bought, the entire fleet, we bought single stage pumps for a city that's going like this.
Right, well, we're the same way. We never discussed this. So.
Right, so you gotta, like fire trucks, we gotta have that double stage pump for 1. And 2, buildings like that, like even the low zone for that building, pumping at 250.
Right.
I don't want my engine sitting there hooked up to that pumping at 250 for how long? You know, during a firefight. So you're going to have to get water supply. You know, these trucks coming in, you're going to have to understand that. Where's all of our hydrants? You need to put a truck on each hydrant and pump from one to the next so that you're not burning up trucks. And then, you know,
That's interesting.
Yeah. All right. And another thing inside the pump room, here's a fire department test header. Once a year, this is required to be flowed and PETO'd outside to make sure you're getting the proper GPM and pressure. Inside the fire pump room, it's kind of a bad picture, but it was the best I could do here, is this right here is the control valve for the fire department test connection. So this is the control valve inside the room that's always in the closed position. It's only open once a year. It's open once a year when this is happening, right? It's a test. All right, so this is basically, I already hit these numbers before, but the 3 main things when you're looking at inspection, testing, maintenance is that you need to have that churn, design flow, and the max flow. So we're not getting, at design flow, you're getting 100% of the capacity at 100% of the pressure. At max, you're getting 150% of the volume with 65% pressure. I might have that backwards. Start with 65% of. No, I think that's right. All right, that's basically it, guys. You have anything else to add or questions, thoughts? Good?
We're going to go out.
Yeah, if you want to take a quick break, if you want to hit the bathroom or whatever, we'll go outside. Just basically break down right from the get-go into the building, right? So if we are coming into the building, this will be our supply. This one in particular is fed by 2 holding tanks, all right? So the supply comes in, and we have our supply OS and Y, right? So coming in this side of the
Can I
pump.
just ask a quick question? Could the supply be the same as the residential water? Has to be completely separate.
What do you mean same as residential water? You mean like a public main?
Yeah.
Like the backflow and everything. I think
Yeah, well, the backflow would prevent water from the 2 systems combining.
Okay.
So this is directly tied into the city water main, right? So the water main comes up, and then you have your backflow preventer before it comes into the building.
But you never share like a
But they never share,
one
yeah.
backflow.
Right.
No, but
Yeah.
it's that makes sense.
Sometimes you'll see two backflows from the building. One will be red and one will be blue. You know the painting? The red is the fire protection and the blue is for the domestic service. Right, so you have your backflow outside, and then you come in and you have your control valve for the supply. And then you also have control valves on the discharge side as well. If for maintenance guys that are going to operate on it, you would have to shut off the supply control valves and also the discharge control valve to work on the pumps. All right. So, and then if you look, what happens if the pump is being worked on and both of the supply valves are closed? How does the building get its water? There's a bypass loop here. These bypass valves are always in an open position. So there's always an open position if the fire pump is being worked on or if it fails. This way the building at least has the city pressure coming in and still supplying fire sprinklers, if one were to discharge. However, you're not going to get the system demand because the pump is down, or at least there's an adequate water supply coming in, right? So city main is usually like 50 to 60 psi, sometimes even higher depending on where you are. And you'll have your suction, your intake pressure gauge, and your discharge pressure gauge. Right. So when we come in to a building, if we're there, we get assigned to fire pump room as firefighters. When we come inside, is the pump running? If it's running, we want to look at the suction and the discharge pressure. If the suction pressure is pretty low and the discharge pressure is fluctuating a lot higher, then that means that water is probably flowing right through a sprinkler head, right? The only way that the suction pressure will be up higher is if it's just running at churn, right? So you have that drop in pressure is with the residual. So we would come in here if there was fire and this is running, and we would look at our discharge pressure, and that's what we would tell our driver outside, hey, I got a fire pump that's running at 150 or a fire pump's running at 200. So they know what pressure to overcome on the outside going into the FEC.
And there's no placard on here that would tell you and give us
There
anything.
is a the placard for this pump in particular. We were just talking to Adam about it in the last class. He said he was going to try and get one put back on it. It's not on this. That's why this morning, I was in the office. I put that picture of the placard in the presentation just so you guys can see what the placard typically looks like and some of the things that are usually on there. So we can come in beforehand with a pump not running like this and look at a placard like that and look at the max pressure and the net rated pressure and look at the suction and basically just add the suction that's coming in to that max pressure, and that's typically what the fire pump is going to be running at.
Oh, okay.
That's what the pressure that we're going to have to overcome to get water into the building. So if you have a suction of 75 and the max pressure on the pump of 225, you're basically looking at about 300 psi that we're going to have to pump into that building.
And the FDC just go through the bypass in case they pump down. You guys just go through the bypass or a different pipe completely?
No, the FDC that we're pumping into is on the discharge side of the fire pump.
Okay.
So it would be, tied into the building, it would be on this side. And we don't pump past that check valve, right? So this check valve right here, if we had the FDC coming up to there, we wouldn't be pumping past that check valve unless we were exceeding the pressure of the fire pump. So that's what I was saying, as fire service members, we have to understand that we're not augmenting or boosting the pressure. It's either that or us.
Even if the sprinkler's going on?
Even if the sprinkler's going on. Yeah, it's either that fire pump or it's us.
Like
it's one
you
or
said,
the
I
other.
was always taught, supplement, give it maximum.
And so was I.
Yeah.
I learned that from day one in the fire academy.
Wow.
Supplement the fire pump.
Yeah.
Okay, supplement. So you mean boost pressure? Yes, you're going to boost the pressure of the fire pump. That's how I've always understood it.
Yeah.
But if you don't know what the pump is putting out, because the actual tie-in would be like here
Right.
with your FTC plumbed a different way, because this is your check valve. So as you come up with pressure, this will close, and now you're pumping the system to pump.
Right.
Now just turning. Now the other option is if you can do it on the suction side. Now you're giving extra water, if that's what you need. If you need pressure, though, the pump's only going to do whatever it's going to rate.
Right.
It's rated at. So if you don't have enough pressure on the fire floor, then this is where you want to be. So what they did, it always pumps. You pump into the system on the discharge side of the pump with a check valve in between, so you're not pushing the water back.
But then the pump won't be working.
It'll run,
Yeah, the pump's
but
gonna run.
they run all the time anyway.
Yeah.
They run every week anyway, or they should.
But the pump won't, that check valve will go down and now the water's just coming through the FDC.
Right, and then we would be taking control. It'd only be our water in the system. The fire pump would still be running for diesel. How long is the diesel going to run for? It's on a run timer, 30 minutes.
Yeah.
The electric will run for 10.
Unless your pressure goes down, then probably the check valve then.
Right, unless, well, yeah, if we lose pressure and the fire pump is running, then yeah, it's basically like that fire hose valve opening or sprinkler head opening again, and the fire pump will continue to push water through the system. Right, and this is the relief valve up here. Right. We have the jockey pump over on this side. Right, so the jockey pump, typically very small. Again, like I said in the class, it's a maintenance pump to prevent the main fire pump from kicking on. And, so remember I told you we got a leaky sprinkler head? Alright, so the pressure in the system drops and the jockey pump kicks on to prevent the fire pump from activating. Alright, so that's basically the purpose of it, and that's why they refer to it as a maintenance pump.
Should you see water coming out of that drain?
Yes, when the pump is running, water will be coming out of that drain.
Running. There's a couple buildings where the pump's not running, but there's not a lot, but significant water continually going down there.
Yeah, and that's probably coming through the packing, which I believe they say a drop per second out of that packing.
You talking about like the wet seals also you call it? Or no? The wet seal something different?
It's basically the packing, like the grease and the packing that they put on the ends of the shaft, the pump. That's basically where it's coming from. Right? You have the battery charger, the battery system right here. Again, off the ground. You know, everything is designed a certain way. It has to be, you know, off the ground, out of water. If you come over to this side, this is for the diesel pump. This is that cooling loop that I was pointing at in the picture. All right, but obviously here you can see it. So you can see that this right here is the automatic line because the valves are open. Right, so when the motor is running, the water is going to flow through here off the discharge side of the pump, running back through it to keep the engine cool, to not allow for overheat. All right, and if we came in as firefighters and the fire pump was running, one thing that we want to make sure is that the fire pump is going to continue to run. So we're going to monitor stuff like these gauges here. We're going to look at the oil pressure, the tachometer, make sure it's not exceeding its RPMs, the water temp. If this starts getting hot, we have to start troubleshooting. Feel the motor. Is the motor getting hot? Oh shit, this thing is burning up, and you know it's helping us in our firefight. We want it to run. We want to work off the system. So one thing to consider is, well, maybe it's not cooling itself through the automatic cooling loop system, or maybe it's not open at all. Maybe somebody forgot to open those valves. One of the biggest problem in fire protection systems, anytime that there's a failure somewhere along the line, is that there's a closed valve somewhere. So during some kind of maintenance, somebody might have come over here and closed them and not reopened them, and it's not recirculating that water through. So that's one thing we're going to have to look at, is the cooling loop valves open automatically. If they are, and we're still exceeding pressure or temperature, and the motor seems hot, well, maybe we should try manually open these things. Let's manually open that line to see if we can cool water on our own. All right. This one over here, remember we were talking about the test header? So the test header, this is the control valve for the test header right here. All right, so there is no check valve from the test header to the pump.
No, you just have one control valve, that butterfly valve.
Yep. Okay.
So the back feed, you gotta make sure that's open and open the...
And go into the pump room and open that. Yeah. And if you saw in that picture, that supply valve, you know, when all these valves are installed and NFPA requires all the signs, they just send a sign that says control valve. Right? So you may see a sign hanging from all these things that just say control valve, and they're not labeled as to what they are. That particular picture that I took in that building, the guys the engineer for the building and the security, the maintenance people, they are phenomenal at that building, and they have everything labeled. So in that room, I went into that room to show some of the guys the fire pump, and we're going to look for the fire pump, the test header supply control valve, and it's labeled. It says the standard sign, control valve, the white sign with the red light, with the red stamp on it, but in a permanent marker, they wrote test header, and then they also say underneath it, normally closed, so that you know that this is the test header control valve, and it's normally in the closed position, right?
But now, how would you know which one it was of all these 5?
Inside of the pump room, you would basically follow it back out the wall where the test header is. Like in that picture, if you can remember, the pipe kind of went this way and then dropped down and then went out the wall. Right on the other side of that wall is the test header. So you just look and see where your standpipe connection is, your FDC, find the test header, and the hydrant. They're usually all very close to each other. And sometimes right there on the outside of the building, you'll see the exterior door for the fire pump room. And you can have maintenance guy unlock that door, and you walk right in there, and you can basically stand in the doorway and see the test header here and the pipe right here running to the pump.
And it should just be one check valve that you're opening to get the water to the pump.
A control valve.
I'm sorry.
Yeah, control valve.
This one to reach, or just that one by itself.
This is set in, this is add extra stuff in here to show, highlight other things.
So it's just one.
Where's the test header here? There. Follow the pipe back.
Right.
Okay. Yeah, you have a check valve there, but realistically, it would come back here. It would come from the discharge of the pump. So, and then this one is going to make it a little more elaborate. Yeah, this has got extra stuff.
We'll trip an alarm back at the fire alarm panel. You'll have a trouble or a supervisory, meaning that there's something wrong with the system, and a lot of times it's the closed control valve.
If you hook up to this, you're gonna have to go to the panel and shut it off because it'll shut it off. If you hook up to the test header.
If you hook up to the test header
Yeah.
to pump the building,
Yeah.
like under emergency circumstance.
Set off the. I mean, the panel will probably be going off. But
Yeah, the panel will be going off anyways because of water flow. If there's anytime that you have water flow in the building, you're going to end up having a fire alarm, and a full fire alarm. Closed valves like this won't generate a full fire alarm, but at the fire alarm control panel, it'll be beeping, and you open the panel and look, and it will either say supervisory or the light will be lit up for supervisory and trouble, meaning that there's a closed valve. The supervisory function is for the valves, like a tamper switch will send a signal back to the fire alarm control panel for supervisory function if a valve is closed. And the trouble indicator on the fire alarm control panel is usually for something else in the system, like dampers and stuff, like HVAC stuff will send a trouble signal to the panel instead of the supervisor.
Now, could you get a flow alarm if there was a dip in water pressure from the supply side? Would that trick it?
If there's a dip in water pressure from the supply side?
Yeah, I mean, we get flow alarms and you show up, there's no flow going on. What else could cause that? Someone told me once if the supply, all of a sudden it senses a change, that it'll trigger.
I'm not familiar with that. I haven't heard of a drop on this, like you're talking about like the city water pressure basically on the city supply side?
Like someone opened a hydrant right next to where the supply was, and all of a sudden the pressure dips and it triggers the alarm.
Yeah, I haven't heard of that. I don't think there's any flow switches that would be on that backside. Like a water flow indicator would basically be water flowing through a pipe on the discharge side. Like if you have an open sprinkler head, you're going to have a water flow alarm and the fire pump is going to be running. A water flow alarm with nothing found on the incident, that could just be a problem in the system. They would have to, whatever company maintains the system would have to come out and look at the history on the panel, see where the water flow switch came from that triggered the alarm, and go to that water flow switch and take it apart and replace it. So it's not, yeah. What else? Anybody else have any questions or anything? You guys want to see this thing fire up? So we'll simulate the, we'll open up the sprinkler head out here, and you can look at the sprinkler head, what it looks like. It'll be very quick under just city pressure with the jockey pump, but the jockey pump's not going to be able to keep it up, so then you'll see that boost in pressure. So the water will look okay at first, just for a split second, and then you'll hear the fire pump kick on, and then you'll see the difference in the spray in another head. Right? What else? Anybody else have anything to add? Thoughts? Anybody? That's pretty much all I got for you.